Hi, I'm Ryan Baker, and this is Big Data in Education. Today I'm going to give some conclusions for the class and discuss some future directions for the field. So, it's been a long semester. We've laughed. We've cried. We've analyzed data. We've discussed key methods in educational data mining and learning analytics for exploring big data in education, and how they can be used to promote new scientific discoveries and advance the learning sciences, to promote better assessment of learners along multiple dimensions, and to promote better real-time support for learners. As you can see, there's lots of methods. There are lots of methods for exploring the big data now available in education. We've gone through most of the ones that are currently most prominent, but this is always changing. To see what's most prominent next year, follow the EDM and Learning Analytics conferences and journals. Everything EDM does is free and open access to anybody on the planet. Learning Analytics, you got to have a subscription to the ACM Digital Library, so find a colleague or a library that has that if you don't have it yourself. The field of data mining is changing quickly, and sub-areas like educational data mining are changing with it. Some of the new ideas in other areas will eventually transform educational data mining, but some of them won't. We don't know entirely right now which ones will or won't. So, for some final notes. When there's a research question, there's a good analytical or statistical method for it. Occasionally, you have to invent that. But make sure to check first for a method that someone, or some of the research community, has already developed and refined. A lot of the methods that I discussed today came from general data mining, but others came from areas like medical informatics, or bioinformatics, or psychometrics. If you're going to reinvent the wheel, don't reinvent this wheel. And I got this photo off the web. I don't take credit for it. It's cool though, isn't it? To put it another way, anything that's worth doing is worth doing badly, as Herb Simon said. But it's even better to do it well. And to be able to determine which way is better. If you don't know which way is better, how do you know you're doing it well? So some potential future directions for the field. More and more constructs will be modeled. And this is going to make methods like discovery of models ever more feasible and powerful. The constructs we're already modeling will be modeled better. There's been so much change in the time I've been working in this field. It's been amazing. The low-hanging fruit is going to disappear, and we'll move towards the slog that characterizes more mature fields. We've already seen this for knowledge inference. Knowledge inference is no longer having like big changes that make a transformative difference. It's kind of very slow incremental improvements. However, I say that, and I feel kind of like an idiot for saying that, because there's so much more low-hanging fruit today than there was 3 years ago. Foundation models have exploded open some problems that long seemed hard to intractable, and now it's possible to do things that it didn't seem like we would be able to do anytime soon. Whole areas which were mature, which were a slog, are suddenly easy again. So, I don't know. Maybe I'm wrong. Maybe there's still more periods of explosive low-hanging fruit to come. Some more potential future directions. Validation will become more and more stringent. This is another one that maybe it's more of an aspiration on my part. I feel like validation in our field became more stringent for several years, and then there have been a couple influxes of people from other communities, and when you get enough of those people, they set up their own validation standards, which are often much more lax. An example of this would be in knowledge tracing. In knowledge tracing, it became the practice that you had to validate your models on new unseen students. And then there was a period of time where so many people were coming in from computer science, completely ignoring this issue, even sometimes completely ignoring issues of the same data point being in the training and test set. And because there were enough computer scientists who'd come into the field who weren't aware of these issues, a lot of papers got published even if they had the issues, because they managed to get lucky and have all reviewers that had those lower standards. That's stopped now again. But I think as we see more influxes into the field over time, there will be periods where validation may become less stringent. Everybody watching this, don't be part of that. You want to make sure that your models are valid. You want to make sure they're not going to make the world worse. Please, try to set yourself to the highest standards. Educational data will keep getting bigger. Gosh, that just keeps happening. And it's going to keep happening as new technologies built on foundation models scale further than the previous EdTech. We'll see data sets that become 10 times bigger than even we're seeing now. Big educational data will become easier to get. As we've talked about during this class, there's more ways to get open data sets than there used to be, and that'll continue. And foundation models will just keep getting more and more awesome. It's amazing how awesome they've gotten. The moment of greatest awesomeness is still here to come. Exploding fruit. Another area of potential future direction is that I think we'll get better at using the results of EDM analysis, figuring out how to use it to drive more and more sophisticated automated personalization. And we'll also get better at using it to incorporate instructors and other expert humans more effectively into the decision loop. In other words, if we can give better information to instructors, other key folks from EDM, we can use that information to make outcomes better for students. And we can do that through dashboards, which give information to instructors in real time or near real time, but also to inform better design. There have been a lot of examples of how EDM has helped us to figure out what designs work and what don't to inform designers so they can make systems better more quickly. In other words, EDM analyses can be useful in a couple ways. We can use it to make software better on its own, or we can use it to give better information to human beings so that they can make the software better or make decisions in real time based on that information. Another area of potential future direction, educational inference and prediction will become more and more effective. And the societal questions of how and why we use these methods will become bigger than the technical questions. We'll be able to tell where students are, we'll be able to tell where they're going, but how we use it will remain a subject of great debate.
So that pretty much wraps us up. But I hope that this class, even though it's ending, is just the beginning of your foray into educational data mining and learning analytics. To learn more, follow me on LinkedIn. I put all of my latest papers and results up there. Or you can follow me, at least right now still, on Baker EDM Lab on Twitter until that website goes bankrupt. Or you can follow Baker EDM Lab on Facebook. Or just come to Educational Data Mining or Learning Analytics and Knowledge and come say hello. I look forward to meeting you, and I look forward to learning what you can do to make education better for kids. This has been Big Data in Education. Thank you for joining me and my colleagues for our 10th anniversary edition.